Time for graphing. You've graphed many functions over your study of mathematics. You've graphed lines, parabolas, rational functions, radical functions, logarithmic functions, exponential functions. You've done so many, but now we need to graph some trigonometric functions like sine, cosine, tangent, and so on. When we were graphing previously, we just always started with our coordinate grid. This was our x-axis, and it counted by whatever we want to scale it, maybe 1, 2, 3, 4, 5, 6, and so on. And this was our y-axis, and we just scaled it, counting by ones again. When we graph trig functions, though, you'll see it's a little bit different looking. Typically, this is 1, this is -1 on my y-axis. And then the x-axis, we're actually going to increment differently. We're going to count in radians for the x-axis, if you want to think of it that way. So we're going to have pi over 2, pi, 3 pi over 2, 4 pi over 2, which is 2 pi, and so on. So it's going to be a little bit different than what we've had when we've done our previous coordinate grids. So you probably remember from our unit circle that sine is our y-coordinate and cosine is our x-coordinate. So when we try to graph these coordinates, they create a periodic. The graphs are considered to be periodic, meaning they repeat after a certain period. So for sine and cosine, they repeat themselves after a period of 2 pi. So this table summarizes everything, but it probably won't mean much to you until we look at a few examples, and then we can go back and look at it and kind of piece it together and make sure it's making sense. So here we have our generic forms, which we always have for all of our functions. This is the sine function, this is the cosine function. And let's just graph the parent function. So right here, you can see that sine starts at 0 and it goes up to 1 at pi over 2. This is pi, so half of that. Then it comes back down to pi at 0. It goes down to -1 at 3 pi over 2, and then it comes back up at 2 pi, and it just repeats. What I've highlighted in yellow is one period of sine, and if it helps, you can mark on your axis what these are. This is 3 pi over 2 right here. All right. Cosine, on the other hand, starts up here at 1. It comes down to 0 at pi over 2. It goes to -1 at pi, back up to 0 at 3 pi over 2, and then ends at 2 pi at 1. And again, if it helps you to put those numbers on so you can tell where you are, feel free to draw those in. All right, so why are these? Okay, so I want to bring you to a video that kind of helps you visualize this unit circle a little bit. I'm going to bring it back to start. All right. And then the video repeats. I'm going to actually pause the video so that you can kind of see what's happening here, because it just kind of goes pretty quickly. Remember, from the unit circle, this is our y value right here. So all of these y values are being shown onto the wall here. As I go around the unit circle, y is getting higher and higher and higher until it gets to here. And then y gets smaller and smaller and smaller until it's 0 again. Then it gets lower underneath to -1, and then it goes back to 0. So sine is the y values. At the same time, this is our x value. So our x value starts out being 1 at the very beginning, Then x approaches 0 right here. It becomes -1 over here. And finally, x is 0 again right here. And back up to 1. So when you watch it, watch it go around this circle and watch how the graphs are created. All right. So now that we know what the parent function looks like, we can start talking about all the different transformations that we can do to both sine and cosine. We can shift them left and right. That's what we call a phase shift. We can move them up and down, vertical shift. We can stretch them, compress them, reflect. All of these same transformations we've been able to do, we can still do for our sine and cosine. The amplitude is kind of the height of the wave, but you have to first put the midline going right through the middle of your sine or cosine, because it goes from the middle up to the very top of the wave or from the middle to the bottom of the wave. That's how tall it is. That's the amplitude. That's going to be the A value. The A value comes right after the equal sign. So you can see right here, my amplitude is 1/4, which means from the midline up to the top of the wave, it would be 1/4. So let's practice graphing some of these with various amplitudes. So first we're going to put the parent function on the graph. I'm going to do that in pink for all three of these. So I'm going to mark this one, and this one, and I'm going to graph them in pink. Cosine again starts at 1, and it ends at 1. Right here it's at -1. Oops, I made my -1 too low. Here we go. And it repeats. So this is my cosine, my parent function. All right, let's do sine. Sine starts at the origin. It goes up to 1, back down to 0, down to -1, back to 2 pi, and it repeats. I'm going to connect these. It does continue on after it goes to the negative part, but we're just not looking at that part. But it does continue on in both directions. Okay, again, we have another cosine one. Starts up here, comes down, -1. So at first glance, these graphs look very similar to each other. Sine and cosine are just these squiggles or waves, but sine goes through the origin, cosine does not. Cosine goes through the point 0, 1. All right, so to graph the next piece, I'm going to do this part in blue. Here's what we want to do. 1/3 cosine x means instead of it being 1 unit tall like it is right now, from here all the way to the top of the wave, or from here to the bottom of the wave, instead of being 1 unit, we want it to actually be a 1/3 unit. So instead of going all the way up to 1, I'm only going to go up to 1/3. And I'm only going to go down to 1/3. Up to 1/3, down 1/3. Instead of up 1, down 1, I'm going up 1/3, down 1/3. So you can see that that 1/3 fraction really flattens out our cosine. Makes it much flatter. It is a vertical compression because 1/3 is less than 1. Next, we'll take a look at this one with an amplitude of 5. We're going to need to actually extend our graph a little bit because it doesn't go up high enough or low enough. Okay. So I have 1, 2, 3, 4, 5 would be all the way up here. -1, -2, -3, -4, -5 would be down here. And again, instead of going from 0 up to 1, we go from 0 all the way up to 5, back down to 0, all the way down to -5, back to 0, up to 5, 0, -5, 0. So when we connect them as smoothly as you possibly can, you can see that it is a vertical stretch from the parent function. And finally, 2 cosine. We don't really have to extend our graph that much. This is 2. This is -2. Starts at 2, comes down, up to 2, down to -2, and so on. Another vertical stretch.